Okay, this is video 2 for NTI day number 4. I really forgot the most important thing in video 1. Since we've had so much time off, I've been writing songs in my spare time. The most recent song was a song I wrote about tortillas, but it's not really a song, it's more of a rap. Okay, so we'll go ahead with our example. In the first video, we were talking about how to characterize the mean and standard deviation of a sampling distribution of a sample proportion. And here I've got an example. Sports Illustrated asked a random sample of 750 Division I college athletes, do you believe performance-enhancing drugs are a problem in college sports? Suppose that 30% actually think that drugs are a problem. In other words, that 30% is going to be the true mean of our population. So p hat is the sample proportion of those who say drugs are a problem. So our first question, the sampling distribution of p hat has a mean equal to what? And so we have to ask the question, the mean of p hat, the mean of p hat is equal to p if the 10% condition is met. So we have to ask ourselves, is the 10% condition met? Well, n equals 750. For the 10% condition, that would mean that the population would have to be bigger than 10 times that, or 7,500 Division I college athletes. And I don't know the exact number, but I'm pretty sure it's more than 7,500. So we can say that the 10% condition is met, and therefore the mean of p hat is simply equal to the true population mean, which is 0.3. Second question here, the standard deviation of the sampling distribution is about what value? Well, we already said the 10% condition has been met, so we can simply say standard deviation of p hat is equal to the square root of p times 1 minus p all over n. Well, plugging in our values, we have p, which is 0.3, 1 minus p would be 0.7, and n in this case is our sample size of 750. And when we do that calculation, we get a number pretty close to 0.017. So C is the best answer there. So now the third question is, if we decrease the sample size from 750 to 375, how would we change the standard deviation? In other words, we make sample size go down by half, what happens to the standard deviation? Well, we'll do a little bit of algebra here. I'll start with the equation p. The standard deviation of p hat is p times 1 minus p over n. Well, I'm not changing anything here in the numerator. All I'm going to do is I'm going to multiply the denominator by 1/2, or same thing, dividing it by 2. But I think we can see the algebra a little bit better if I just multiply by 1/2. Well, dividing by 1/2 is the same thing as multiplying by 2. So the 2 comes up here, 1 minus p over n. And now, using the rules for radicals, I can take that square root of 2 outside by itself, and now I just have the original value for the standard deviation. So what happens is I take the original and I multiply it by the square root of 2. So the best answer here is we multiply the standard deviation by square root of 2. Now notice what happens. If I reduce the sample size by half, the standard deviation increases by square root of 2. Reducing sample size increases variation in my distribution. So now we're going to ask the question, the sampling distribution of p hat is approximately normal because, well, why is it approximately normal? We have to go back and check our two conditions. Our two conditions were n times p has to be greater than 10. Well, in this case, n times p is 0.3 times 750, which is a number, I think, 225. And n times 1 minus p is 750 times 0.7, and that number is, I think, 525. So both of those are greater than or equal to 10. And so we know that the sampling distribution is approximately normal because those two conditions are met. So B is the best choice there. Okay, if you have any questions, feel free to shoot me a message on Classroom or email. I'll be happy to answer any of your questions. Y'all have a great day 2.